Hello and welcome to this part about PREL position control function. We start with creating new project and check the hardware configuration. We should use some transistor model to produce pulse train output. It means models that have AX or AT at the end of the code. Then we can come back to our main program environment. Then we should go to instructions part, and in the position control category we can find PREL function. It is a relative position control function, and it will cause some movement from the current position until the target distance that we set in distance operand. The en operand is enabling command for this function, and we can use some bits such as SM0.0 for that. In access operand we can choose 0 or 1 to select between Q0.0 or Q0.1 to produce pulse train output. In the exec operand we will use some bit memory to send the run command for the function. In the minf operand, we should select minimum frequency in word format. And in the maxf operand, we should enter some double word value for maximum frequency. Then in the time operand, we should enter acceleration time from minf to maxf. It is based on millisecond and in word format. In the distance operand, we will set the number of pulses for the movement in double integer format. Then, each time that we active the exec operand, we have this number of pulses in the output. We should pay attention that this function is some relative position control function. So every time that we active exec operand, we have some pulses in the output that cause our motor move from current position to another next position. Okay, for understanding better the work principles of this function, we have some picture here. In the next picture, we have three positions A, B, and C. And also, we are using one servo package from Kinco that rotates one round per every 10,000 pulses. We will assume that A is our origin and 0 point, and B is second point with 100 round rotation, and C is 300 round from A position. If we want to rotate the shaft of the motor to reach from A to B with 100 rotation, in the distance operand we should enter 100 multiplied 10,000 in double integer format. So the shaft of the servo will rotate 100 RPM and then stop. If we want to move our axis from B position with 100 rotation to the C with 300 round rotation, then in the distance operand, we should set 200 multiplied 10,000. So after additional 200 round rotation, and when the total rotation becomes 300, the motor will stop. And finally, if we want to come back from C with 300 rotation to the B with 100 rotation, so it should rotate 200 round in reverse direction. So in the distance operand we will enter minus 200 multiplied 10,000. Okay. Let's go and continue in the main program. The down operand indicates that operation is finished and work in bit format. The error operand indicates that we have some error in the function with bit logic format. And the error ID operand will indicate the error code in byte format. And we can check these errors by pressing F1 in the help menu. As mentioned here, 0 means we don't have any error. And 1 means that the value that we set into the axis is not 0 or 1, and it's not correct. Before discussing about the error code number 2, please pay attention that in K5 CPUs, the maximum frequency in Q0.0 and Q0.1 is 200 kHz. So the error number 2 means that the min f is larger than maximum frequency or 200 kHz. The error number 3 means that the min f is not correct and it should be upper than 125 Hz. The number 4 means that our acceleration or deceleration time is not correct choice for our min f or max f. And finally, error number 5 means the value of min f operand is larger than the value in max f operand. Okay, let's come back to the main window and test one example. We have one servo motor and we want to stop it after 10 round rotation. So we will try to set the values for operands. SM0.0 is one bit that is always active. I will set minimum frequency to 5 kHz and maximum frequency to 10 kHz. And also the acceleration time 1 second. And in the distance operand, I will enter 10 multiplied 10,000. The important point is that we should use one type of data for all of the operands in position control functions. For example, we should use memories for all of them or fixed value for all of them. We cannot use mixed of values and memories. Okay, then we can compile our program and download to the PLC hardware. Then in the online monitoring mode, I can check my program. By activating the exec operand that I assigned I0.0, the Q0.0 output will turn on and produce pulses for 10 round rotation and then set to off. Thank you for your attention to this part.